Welcome back to this course on advanced memory hierarchy design. The topic of this lesson is techniques to reduce the cache miss penalty. I will now present a few miss penalty reduction techniques. The first one is early restart. When we have a miss, the words contained in a cache block usually arrive one after the other, maybe two at the same time, but not all at once. There is no fundamental reason why we have to wait until all words in the cache block have arrived. So the early restart technique is to send the requested word to the CPU as soon as it arrives and to let the processor continue executing while the rest of the block is being filled. Let me illustrate this with an example. Suppose there are 8 words in a block and that the requested word is word 3. In a conventional blocking cache, the timing diagram of a miss looks like this. The CPU computes for a while and then it incurs a miss. Then it takes some time before the first word arrives and then the words arrive one after the other. Only when all words have arrived, the CPU continues executing. Under early restart, the timing diagram might look like this. The CPU does not wait until all words have arrived, but continues executing as soon as the requested word, in this case word 3, has arrived, and the rest of the block is being filled while the CPU computes. A small enhancement, at least in theory, of early restart is critical word first. In this enhancement, we do not request the words from the next level in normal sequential order, 0, 1, etc., but first request the missing word and send it to the CPU as soon as it arrives. Again, this shows the timing diagram of a miss in a conventional blocking cache. The CPU resumes only when the whole block has been fetched. And this shows the timing diagram of a miss when we apply critical word first. First, the missing word, word 3, is fetched, and as soon as it arrives, the CPU continues executing. The remaining words, words 4 to 7 and 0 to 2, arrive while the CPU is executing. In general, both early restart and critical word first only improve designs with large cache blocks. The second miss penalty reduction technique I will discuss is called merging write buffer. Finally, a short recap. Recall that the CPU does not have to stall on a write, but can continue executing. For this, it uses a write buffer that buffers data and its address until it is written to the next cache level or main memory. The CPU simply continues and only needs to stall on a write when the write buffer is full, which, if the write buffer has sufficient entries, should occur very rarely. A write buffer is absolutely necessary for write-through caches, but also write-back caches employ a write-back buffer for replaced dirty blocks. A merging write buffer is based on the observation that writing multiple words contained in a cache block is usually faster than writing several single words. The entries of a merging write buffer, therefore, correspond to cache blocks rather than single words. If the CPU then writes to a block that is already present in the write buffer, this write is merged with the write already present in the write buffer. For this to work, we need a valid bit for each word, since maybe not all words in a block need to be written. In fact, we need a valid bit for each addressable data item. So if we can write bytes, we need a valid bit for each byte. An example. This shows a conventional non-merging write buffer. The CPU first writes to address 200, then to 400, then to 208, and finally 408. In a merging write buffer, the writes to 200 and 208 are combined into a single write buffer entry, and the writes to 400 and 408 are also combined. Later, if the first entry, the one at the top, is written, memory addresses 200 and 208 will be written, but not 216 and 224, since their valid bits have been cleared. A problem of a merging write buffer is, however, that a write may overtake an earlier write. This is a problem for shared memory multi-core systems. I will return to this issue in the course on multi-core systems. Finally, 2 exercises. The first exercise is, do you still recall what wave prediction is, its goal and disadvantages? The second question asks you to explain the difference between critical word first and early restart. This concludes this lesson. Thank you for watching. In the next lesson I will describe several techniques to increase the cache bandwidth. Hope to see you back.